Myself, Ketan Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, Electrical Engineering Department. Subject is Testing and Commissioning of Electrical Equipments for the 8th semester. And chapter is Transmission Line. Okay, now chapter number transmission line. First is commissioning of AC transmission line, HVDC transmission, galvanized steel structure, tower for transmission and distribution line. Now, classification of transmission line: short transmission line, medium transmission line, and long transmission line. Now, what is the transmission line and how it is used in all sectors? Electrical power is generated in the power stations. It is necessary to send this power to the different remote area, so that with the help of distribution substation, the power can be distributed. Flow of power from the power stations to the main distribution substation is called the transmission. The transmission network are high voltage transmission lines which transfer bulk power from the generating stations to areas of consumptions. The standard voltage used in India are 400 kV, 132 kV, and 110 kV. There is a recent development of 765 kilovolt transmission line. In short transmission line having a larger less than 80 km or 150 miles and operating voltage less than 20 kV are generally known as short transmission line. Due to the small distance and low voltage capacity, effect is negligible. Hence, performance of these lines depend upon the resistance and inductance only. Although the resistance and inductance are distributed along the line, but in short lines these constants are assumed to be lumped at one phase. Medium transmission line: the transmission lines having length between 80 km and 240 km and line voltage between 20 kV and 100 kV are considered as medium transmission lines. Due to appreciable length and voltage of line, charging current is appreciable and therefore capacitance effects need to be considered. Although the capacitance is distributed uniformly over the entire length of the line, yet it is assumed to be concentrated at some or more points. In long transmission lines having a length above 240 km, line voltage above 100 kV are generally considered as a long transmission line. Okay. Now, in HVDC transmissions, high voltage DC transmissions, it is necessary that from economical points of view, the voltage of transmission should be kept high, but at the same time, we studied then there are some limitation of high voltage AC transmission system. Now the questions arise that can we overcome these limitations? The answer is yes, and it is that use the voltage DC transmission instead of high voltage AC transmissions. Idea of high voltage DC transmissions was in consideration for the long time, but amount of power to be transmitted was not much and the distance was also less. So HVDC did not prove economical. Moreover, high voltage equipments were not much developed. Mercury arc rectifiers and inverters were used, but it was not possible to convert the voltage to the high value. After 1990, the HVDC has become popular as high voltage thyristors are developed. For transmissions, use of high voltage DC has become possible, but the voltage of generations has remained AC. Say the figure, first is the first power grid network, or we can say generators. Then step up transformer, okay, it's HVDC transformers, and then converter to rectify the voltages. Then the transmission line is number of kilometers then again inverters to step down and transformers, and voltage gives to the electric transmission line. Okay, means second power grid networks. In HVDC systems, it is the difficult to generate high voltage DC due to the difficulty in commutations of HVDC systems can be called the hybrid systems. Power is generated in power stations in the form of three-phase AC. This voltage is stepped up by the step up transformer. With the help of static rectifier, this high voltage AC is converted into the high voltage DC. Power is transmitted at high voltage DC through high voltage DC transmission line. With the help of static inverters, the high voltage DC is converted into the high voltage AC at the receiving end. Using the step down transformer, the high voltage AC is converted into low voltage AC to required value. From there, the LED transmission lines are run in different area. Now, advantages of HVDC system. First is economical transmissions bulk power. By HVDC systems, the bulk power is transmitted to the distance more than the break. At the break-even distance, the cost of terminal equipment is balanced against the cost of conductors and poles. It becomes economical when the distance is more than the distance. Now, decreases in the number of lines. For the transmissions of bulk power, three-phase circuits are required. Six conductors are required. Size of the tower. Compared to HVDC, face-to-face clearance and face-to-ground clearance required is comparatively less in HVDC, and numbers of wires are only two. So the width and length of the tower required is less. So the size of the tower required is small. As a result, the cost of tower is recorded. Reductions in numbers of intermediate substations. In long distance HVDC lines, intermediate substations are required to be installed at the distance of 300 km for the compensations of reactive power. This is not required in HVDC, so the cost is reduced. Earth return. Earth return can be used in HVDC while it is not possible in HVAC, as the lines is always three-phase type. In skin effect, there is no skin effect in DC, so the current density in the conductor is uniform throughout the cross section of the conductor. So full cross sections of conductor is useful. Moreover, there is a reduction in power loss as the effective resistance is less. Now, charging current. There is absence of charging current in HVDC. Corona. Effect of corona is less in DC system than AC system. So the corona loss is reduced in DC systems, and there is no disturbance to the nearby communication line. In underground cable, due to the absence of charging current, power transmission can done through the line underground cable or marine cable. In this, there is no restriction to the length of cable. While in AC system, there is a restriction of the length of the cable. For example, for 145 km line distance is 60 km. For 240 kV it is 40 km, and 400 kV it is 25 kV. Reduction in line losses, power factor reductions in size of the conductors, voltage regulations, stability and line loading, quick power transfer and control, decreases in right of way, asynchronous tie, flexibility in operations, short circuit level are the advantages of high voltage DC transmissions. Now, limitations, or we can say disadvantages of HVDC systems. There are some limitations or disadvantages to the HVDC along with the its advantages. First is cost of terminal equipment. In HVDC system, the rectifiers are used at the sending end to convert high voltage AC into the high voltage DC, and inverters filters are used the receiving end to convert DC into AC. The cost of such terminals equipment is much high. In additional equipments in HVDC systems, some additional equipment like converter, transformer, electrical and mechanical auxiliaries, valve controls, pole controls, etc. are used. All such equipments are high technology and are to be imported. In transmission of DC voltage, in AC system voltage can be step up or step down easily with the help of transformer, but in DC system this is not possible. Hence, this system cannot be used for low voltage transmission and distributions. In DC circuit breaker are still in the development stage and its cost is more than a circuit breaker. Now, systems failure. Possibility of system failures is more in HVDC systems as there are some abnormal operating conditions. And then complicated control, complicated coolings, harmonic filters, power loss, multi-terminal network and overload capacity are the limitations of the HVDC systems. Now, types of HVDC systems. In types of HVDC system, first is monopolar system, bipolar system, homopolar systems and back-to-back systems. Okay, in monopolar system, there is only one pole in monopolar systems, and the return path of the current is provided through the earth or say. Polarity of pole may be positive or negative with a reference to the earth. Mono reference polar system was used in the low power link. Cost is reduced as the earth is used as the return conductor. In polar in bipolar systems, there are two poles in this system. One line is positive with reference to the earth and other line is negative. Midpoint is earth. Some out of balance current flow through the other normal operations. The system comes automatically in monopolar made with there is a difficulty of fault in one pole and the community of services is maintained. The system comes back to the bipolar mode when the fault is clear. There are two conductors in these systems. Voltage of one conductor is positive with respect to the earth and that of the other conductor is negative. There is a double the voltage between the two conductors. So 500 kV systems means one conductor is at 500 kV with reference to the earth and the other conductor is at 500 kV with reference to the earth while the voltage between the two conductors is 1000 kV. Now next is homopolar systems. Uh, there are the two transmission poles in the system but both the poles are of the same polarity and the return path is through earth. Now back to back systems. In back to back system there is no DC transmission line. Two AC systems are interconnected through the converter with this station. Such type of tie-link makes asynchronous interconnections of two nearby AC systems. Now comparisons between the high voltage systems and high voltage DC system. A base of this HVDC and HVAC systems, the effect is corona effect, skin effect, support, stability, effect of capacitance limited due to charging current, reactive losses, Faraday effect, number of line wires, intermediate, use of the earth systems, line loss, power factor, volume of conductor, voltage and regulations, etc. are the base. While the corona effect In HVDC systems over HVAC system, in HVAC system, more power loss is more disturbance to the communication line, while in HVDC, less. The corona effect is less. The power loss is less and no disturbance to the communications line. The skin effect in HVAC, yes, and HVDC, no. Supports in HVDC, light supports are needed, cost is less, while in HVAC, heavy supports are needed, cost more. Stability is less in HVAC and more stability in HVDC. Parent effect in HVAC, yes, and HVDC, no. Okay. So there are the number of bases in HVDC versus HVAC systems. Now, in galvanized structure or mechanical design of transmission line, the number of parameters like supports for overhead line. The supports for overhead line is wood pole, steel pole, RCC pole, and lead-sheet steel pole. In overhead transmission systems, the conductor should be run above the ground from one place to the other. Line supports are used. For this, insulators are kept on the cross arms fitted to the poles or steel towers, and live wires are tied to the insulators. Line supports are made of wood, RCC, or steel. Here we shall obtain information about construction of different types of line supports and their relative advantages and disadvantages. Wood poles are like a single pole structure or A and H type structure. Wooden poles are used in distribution system in this place where the wood is easily available due to the proximity to the forest. Its use of becoming limited due to the increases in the price of wood. Instead, RCC poles are used. Coating and bitumen is applied at the bottom for 0.5 meters to give protection against the moisture and terminals. There are three types of the wood pole structure. First is single pole structure, next is A type structure, and then H type structure. In single pole structure is used for the low voltage and high voltage distribution lines. These are used for the line voltage of 11 kV. This can be used for the maximum span length of 50 meters. Steel cross arms are fitted on the pole over which the insulations are fitted. In A and H type structure, good transverse strength is obtained at 75 meters. This can be used for the line voltage of 11 kV and more. All the three types of wood pole structures are also used. Its disadvantages and limitations are its life is only about 20 to 25 years. These are the liable to rot due to termites and moisture. This requires frequent maintenance. Their mechanical strength is less. These are not useful above 20 kV, so these are used only for distribution systems and cannot be used for transmission lines. Now, steel pole. Steel poles are used for distribution lines and street lighting in city. Its life is longer than the wood pole and face pleasing appearance. It requires reduced maintenance. There is no problem of rotating due to the termites, but there is a problem of rusting due to the moisture. Length of this pole is 7 to 10 meters. 1/6 of the length is buried in the ground and concreting is done around it. Muffing of concrete is done around the pole for 0.4 meter length above the ground to prevent entry of water in the foundations and to provide support to the pole. These poles are used up to the line voltage of 33 kV. Steel poles are used of two tires, rail pole and tubular pole. Old railway tracks or steel poles are used. In tubular poles, hollow round steel pipes are used. Its diameter is entire the four stage over the length. It is broad at the lower portions of narrow at the above. Tubular poles are and steel poles can be used for the street lighting by bending the upper portions. Now, RCC pole, due to the unavailability of the wood poles and increasing cost of the steel pole, the RCC pole or pre-stressed concrete poles are become popular. Its mechanical strength is more and is used for more span length. It does not require maintenance as required in wood pole and steel pole. It is used in low voltage and high voltage distribution lines. What difficulty with RCC pole is its increased weight, which increases the cost of the transportations. So mostly these poles are fabricated near the site. Edge structure can also be made by RCC poles. Distribution transformer can be placed over the next is latticed steel tower. In wooden RCC or steel pole are not useful for high voltage transmission line and for increased span. So latticed steel structure are used for this. These structure are used for the line voltage of 66 kilovolt. This structure is assembled at a site by bolting various parts or the whole structure is made into the 3 or 4 sections and these are assembled at the site. Earth wire is run over the towers so there is a protection against the lightning shock. Poles are earthed at certain regular intervals. Painting is done to give protection against rusting. Mechanical strength of structure is high. It is designed to withstand the severe wind and cyclone. There are two types of lattice steel structure: narrow base lattice steel mast, broad base lattice steel tower. In narrow base lattice steel mast, the base is narrow. It is used normally for the line voltages of 132 kV and less. Span length is less than with the broad base tower. In broad base tower, the base is broad and all the four footings are considered. It is used for the line voltage of 220 kV or more. Height and weight of the tower increase with the voltage. So these are the latticed steel tower. Earth wire is very important in this type of structure. Lighting is greater hazard to overhead lines. To protect the transmission line conductors against shock of lightning, so earth wire are provided at the top of the tower. The height and locations overhead earth wire shall be such that the light joining the ground wires to the over outermost conductor shall make angle of approximately 20 to 30 degree of the vertical. Okay, it is called single angle. Okay, thank you.